In this recording, we're going to look at how to convert recurring decimals into fractions. Now, I have included in the playlist for number some fraction work as well, which you might find useful to review. So just look in the playlist for number higher and you will find some work on fractions. Okay, what is a recurring decimal? So it's a decimal that continues infinitely. So 0.3 with a dot above it means the 3 continues forever. So I could carry on writing 3's here for the rest of my life and they would never end. So what happens if we have 2 dots above here? So this is what I call a single digit recurring number, which is going to be important after. This is a double digit. Recurring decimal. The dot above the 5 and the 7 mean the 5 and 7 repeat. So 5, 7, 5, 7, again, forever. When you've got a dot above a 5 and a 2 with some numbers in between, this means it recurs like 562, 562. The dots above it are like the beginning and end of the recurring part, if that makes sense. So because we have 0.562, 562, again, goes on forever. Because we have 3 numbers repeating, I'm just going to call it a triple digit. So what happens if we have a dot above just one of our numbers? Well, it's 8 that recurs. It's still a single digit recurring decimal because it's just the 8 that repeats. And here we have a dot above the 5 and the 4. So again, it's just the 5 and 4 that repeats. And because we're just repeating those 2 digits, I call it a double digit recurring decimal. Okay, what I'd like you to do now is have a go at writing these out in full, just so you can get the idea of what the dots represent. You might want to put me on pause, have a go in your workbook and unpause when completed. This one here is just the 8 that repeats. Here, the dot is just above the 6, so it's just the 6 that repeats. Here we've got a dot above the 6 and the 4, so it's the 6 and 4 that repeats. Here the dot is above the 3 and the 4, so it's just the 3 and the 4 that repeats. And then for this last one here, the dot is above the 3 and the 2, so it's everything in between the 3 and the 2 that repeats. The 5 has nothing above it, so it's 3, 4, 2, 3, 4, 2, etc. Okay, so we need to know how to convert a recurring decimal to a fraction on the higher paper. And we're going to use an algebraic method to show it, because you can actually just use your calculator. But the way they ask the question, they want you to prove it or show it using algebra. And it's just really a straightforward method for all of these questions. Let me just show you how to do this. We're using algebra, so we're going to use a letter. So we're going to start by letting x equal 0.7 recurring, which I'm going to write out in full. That's my first step, writing out the decimal in full. Okay, now the next step, we're going to multiply this decimal here by 10. So if x is equal to 0.7, 777, 10x is equal to, you can use your calculator if you want, but if you times this by 10, the numbers are moving one place to the left, so it becomes 7.7, goes on forever. Okay, next step. This is really important that you don't skip any steps here. Try to do any shortcuts. And you get used to setting it out in a certain way. We're going to write 10x at the top. Always write the multiplied form at the top. And then we're always going to write the x underneath. But it's really important that we get all our place values lined up. I always set out my decimal point here so it's in the same place. And then each digit, so the units are lined together up. The tenths are, hundredths, thousandths, etc. And again, the next step is always the same. We're going to do the top line, subtract the bottom line. 10x, take away 1x is 9x. Now what happens if I do 7.7777, subtract 0.777? Well, 7 take away 7 is 0, right? So all of these cancel out to make 0. So I usually like highlight through them. And can you see we'd just be left with 7. And then we need to make x the subject. How do you make x the subject? You divide both sides by 9. The answer is 7/9. Then I would suggest maybe checking this on your calculator to make sure it's correct. Here's the fraction button. A bit slow. 7 as your numerator, 9 as the denominator. Format into decimal. As you can see, it is 0.7 recurring. The reason they have the 8 here is just the calculator's rounded. It does actually carry on forever, so we know we're correct. Okay. Next question. I'm going to go through another example, and then I'll have a few questions for you to look at yourself. So this time we're going to be converting a double-digit recurring decimal into a fraction. So, again, using algebra, we're going to let x equal 0.626262. Now, this time I am not going to times it by 10. Let me just show you why over here. If I times it by 10, we have 10x. If I multiplied this by 10, we'd have 6.262626, right? Because the numbers are moved one place to the left. And if I just put my x underneath it, right, well, if we do the top, subtract the bottom, we are going to still be just left with a load of numbers. 6 take away 2 is 4. 2 take away 6 can't do, we'd have to borrow here. It's just not going to be useful for us. So when you have a 2-digit recurring number, we're going to multiply by 100. If it's a single digit, we multiply by 10. If it's double-digit recurring, we multiply 100. And if it's triple digit, you multiply by 1,000. If I multiply this by 100, my digits are all moving two places to the left. So we have 62.6262. And again, I'm going to put my 100x on the top. I'm going to put my x underneath. I'm going to do the top, subtract the bottom. 100 take away 1x is 99x. I subtract these, again, I've lined them up, the decimal point is underneath each other. The tenths are, etc. So you can see 2 take away 2 is 0, 6 take away 6 is 0. They all disappear nicely from here, and we're left with 62. I need to make x a subject here, so I'm going to divide both sides by 92. So it gives me 62 divided by 99, 62 over 99. I'm going to simplify it on my calculator first by using the fraction button. Oh, it doesn't simplify, but let me format it as a decimal. Yes, 0.626262. I'm correct. Okay, just this third one here. So we're going to let x equal 0.671. Everything recurs in between those two dots. As I mentioned before, because it's recurring as a triple digit, I'm going to this time times it by 1,000. So again, if it's a single digit, times by 10, double digit by 100, triple digit by 1,000, just to make sure all our numbers line up nicely. And when we subtract, they can disappear. If I times this by 1,000, I'm moving it 3 places to the left, each number. So it becomes 671.671. Okay, let me write the 100x at the top. I'm going to write the x underneath. Line everything up, and my decimal points here, decimal points here. Tenths are underneath each other, etc. As you can see, if I subtract now, 100x, take away 1x, sorry, that should be 1000x. 1000x, take away 1x is 999x. If I subtract the bottom line from the top line, all of these disappear with these, and we're left with 671. Let's make x a subject now by dividing both sides by 999. I'm just going to check on my calculator. Doesn't simplify. As you can see, if you format as a decimal, you can see that we are correct. Okay, have a go at these 3 questions yourself. Put me on pause, unpause when you're finished to see if you're correct. I'm going to go through each one of these individually. First one is a single digit recurring. I'm going to let x equal 0.555 recurring and multiplying it by 10. I'm going to write the 10x at the top. 1x at the bottom. Top subtract the bottom. 5 take away 5, 0. All of these cancel out. So on the right hand side, we're just left with 5. 10x take away 1x is 9x. On the left hand side, make x a subject. Divide both sides by 9. Check on the calculator. Yes, correct. Question 2. Multiply by 100 because of the double digit recurring. 100x is at the top. X is underneath. Line everything up nicely. Subtract. 100x, take away 1x, 99x. We subtract the right hand side here, all these disappear, we're left with 87. Make x a subject, divide both sides by 99. Check on the calculator. Oh, it simplifies this time to 29 over 33. Format to decimal, correct. And then this last one. Multiply by 1,000. Because it's triple digit. 1000x at the top. One x on the bottom. Line them up nicely. Subtract. 1000x, take away 1x, 999x. Subtract the right hand side, these disappear. You're left with 715. Make x a subject, divide both sides by 999. Check on the calculator. Doesn't simplify, but I can see I'm correct. Okay, let's have a look at these slightly different questions here. I'm just going to go through two, then I'll have you have a go at some yourself. So again, let's just write it out in full. So here, just remember from the beginning, it's just the 2 that recurs here because the dot is above the 2. Right, yes, we've got a 5 and a 2, but it's just the 2 that recurs, so it's a single digit recurring decimal. So I'm going to times it by 10. Okay, I'm going to write my 10x at the top. The x underneath it, but be careful to line everything up. Now, just be careful here. So where do our numbers start disappearing to make 0? 2 take away 2 is 0. So is 2 take away 2, 2 take away 2. They do not disappear here. So I usually highlight the numbers that are the same because they disappear. Let's subtract 10x, take away 1x is 9x. You could work this out in your head, or on the safe side, you could use a calculator. What if 5.2 take away 0.5? It's 4.7. Let's make x a subject by dividing both sides by 9. Now we don't want a decimal within a fraction, so I'm going to turn this into an equivalent fraction by multiplying both sides by 10. So it's 47 over 90 is our answer. Let's check to see if it simplifies on the calculator. No, it doesn't. But if I format to a decimal, I can see it in 0.5222 recurring. It's good to get into the habit of checking that you're correct with these. Right, one more to go through. So let x equal 0.514 recurs this time because the dot is above the 1 and the 4. It's a double digit recurring decimal, so we're going to times it by 100. If I times it by 100, the digits move 2 places to the left, so 51.414141. Just make sure you do that bit correctly. If I move these numbers 2 places, the decimal point will be there, this point here, so you can see it'd be 51.414141. Right, let me write the 100x here at the top. Let me just show you that a bit better here. So if I move them up digits, that's where the decimal point goes. Your numbers don't change. The order of the numbers don't make change, if that makes sense. Some people just change the order of the numbers for some reason. Write my X underneath, but making sure I line everything up. Now, when I subtract 100x, take away 1x, 99x. If I subtract these, where are they the same? 141, 141. What is 51.4? Subtract 0.5, 50.9. Make x the subject. Multiply both by 10 to get rid of that decimal. Put it into the calculator to see if it simplifies. Doesn't, but I can check my answer is correct. Okay, key points to remember. What do you multiply by? Is it 10, 100 or 1,000? It depends. If it's a single digit recurring number, times it by 10. Is it double digit recurring? Times it by 100. Is it triple digit? Times it by 1,000. Remember to line up the place value. So here's an example. So let's say I've multiplied this by 100 because it's double digit. When I put my original decimal underneath, decimal points have to be underneath each other, and each digit also has to be underneath each other like this. So you can see where they cancel out when you subtract. Okay, have a go at these 3 final questions. See how you get on. Put me on pause and pause when you're finished. Times by 10. Disappears from here because 2's are underneath the 2. 6.2 subtract 0.6 is 5.6. Divide both sides by 9. We don't want the decimal within our fraction, so let's multiply the numerator and denominator by 10. It does simplify this time. Let me check. Correct. $100x, double digit recurring. $100x, take away 1x, 99x. When I subtract, they disappear from the 3 onwards. 83.6 minus 0.8, 82.8. Let's make x a subject. So let's divide both sides by 99. Multiply the numerator and denominator by 10. Let's see how this simplifies. To 46 over 55. And let me check by formatting. I'm correct. Last one. Times by 1,000. Thousand X is at the top. X is at the bottom. If you subtract, these disappear. 516.3 minus 0.5 is 515.8. Divide both sides by 999. Multiply the numerator and denominator by 10. Let's see how this simplifies. 2,579 over 4,995. Are we correct? Yes, we are. Okay, now I'm going to do a separate recording on exam questions for this topic, which you may want to watch after watching this revision video.